So section 8.1 starts with talking about rational functions or rational expressions. So something like a rational number is something that could be written as a fraction, right? A rational expression is also something that could be written as a fraction. So take a look at this first question. It says, for what values is the expression undefined? So take a look at this expression. It's in terms of y. And it's asking you for what values, right? That means for what y values is this undefined? Now, when is a fraction or a rational function undefined? Well, when the denominator equals to 0. So this is asking us, when is the denominator of this 0? For what values? That means what should y be for this to be 0? So, okay, so to do this, you take the denominator. If you want to see where the function is undefined, where is a function undefined? When the denominator is 0. So you take the denominator and you set it equal to 0, right? So anytime you have that question, where is this undefined? Something is undefined when its denominator equal to 0. And now we have a cubic function that we have to solve. And then that's where you go back into your chapter 5 and chapter 4 and all that stuff. So to factor this, I take out a y. I have y squared minus 9 equal to 0. So this is y plus 3, y minus 3 equal to 0. So y is 0, -3, and +3. At those 3 points, when y is 0, or when y is -3, or when y is +3, this function or this expression is undefined, right? Because if I take 3 and I plug it into the denominator, I get 27 minus 27, that's 0. I haven't even touched the numerator. Do you see that? Because when I'm looking at, where is something undefined, all I care about is the denominator, never the numerator. I don't care about the numerator. The numerator can be whatever it wants it to be. Okay, so let's move on. So how do we simplify rational expressions? Basically, a rational expression is the ratio of two polynomial expressions. So something in the numerator, something in the denominator. Just like when you're reducing fractions, to simplify a rational expression, you have to divide the numerator and the denominator by the GCF. Okay, so let's take a look at this first one. All right. When you have this, you always want to deal with the numbers separately, then each of the variables separately. So look at the coefficients. I have a 27 and a 9. Both of these can be divided by a 9. So I get 1 here and 3 here. Okay? Now the x's. I have an x squared on top, x on the bottom. That means I have 1x on top. We've done this, right? None of this should be new to you. The y's go away. The z's, I have 3 on top, 1 on the bottom, z squared. So there isn't even a denominator, just 3xz squared. Okay, now, in this case, I have a 4, a y. Y minus 3 is an entity of its own, and y plus 4 is an entity of its own. So the y plus 4 can only reduce with another identical y plus 4, right? Nothing else. Okay, so I look at this. The numerator, there isn't much I can do there, but the denominator needs to be factored, right? So I go ahead and factor this denominator. I get y minus 3, y plus 2. So now let's take a look here. 1y here cancels with 1y there. And then the y minus 3 cancels with the y minus 3. So what I have is 4, y plus 4 over y plus 2. And that's it, okay? That's it. Now, somebody might ask, well, what if I'm multiplying the 4? Can I write 4y plus 16? Sure, no need. Either way will work. But Can you cancel this top y with the bottom y? Absolutely not. Can you reduce, that 4 on the top with the 2 on the bottom? Not at all. All right, those are like big ones. Okay, so let's move on to the next one. Okay, so what about factoring out a -1? So take a look at this one. I have a minus b and b minus a, right? Okay, so look, let's pretend those were numbers, the a and the b. If you have 3 minus 5, how much is that? -2. But if you have 5 minus 3, +2, right? So when you are subtracting two things, switching the order is only a negative mistake or a negative difference, correct? So if I have a minus b and b minus a, I can cross both of these out and it'll be a -1. Okay? Why? Okay, well, let's see why. Suppose, okay, look, you have a minus b over b minus a, right? Let's leave the a minus b as it is. Can we factor out a negative from here? Why not? Of course we can. So if I factor out a negative, this will be -b plus a. Is that right? Okay, so now, well, I didn't want to. I only wanted to do it for the bottom one because it's a free country. And so that's what I did, right? So now I have negative. But look, can I like reverse the order? So write positive a and then negative b? Positive a and then negative b? Look at what happened. They're the same exact thing, right? So they cancel and it becomes a negative. Okay, so let's go over here. We have to simplify things. First, you have to ask yourself if there's anything that we can factor out. Well, of course there is. An a to the 4. And I get b minus 2. Here, a cubed. And I get 2 minus b. Okay, so take a look. The b minus 2 and the 2 minus b, you can cancel them out, but there is a -1 there. So when you do that, especially on the test, write that that's a -1 so you don't forget later. And then what happens with the a's? It's just a. So this just becomes a times -1, which is -a. Cool? Now, if you have, look at this, if you have a plus b and b plus a, can you cancel those out? Is there a negative there? No, right? Because when you're adding two things like 3 plus 5 and 5 plus 3, that's the same thing. There is no negative. Okay, let's factor this out. I can take out an a and a b. So what do I get? B minus 5. Here, I get 5 plus b, 5 minus b. So look, the b minus 5 and the 5 minus 3 cancel out, and that gives me a negative. So here I get -ab over 5 plus b. Okay, now, don't go and cancel those b's, right? Like when I see it, okay, don't write this. Sometimes a student will do this and they're like, oh, it's -a over 5. Oh my God, you have no idea what kind of reaction that gets from me. That's literally when I'm just like, oh my God, like that, like that's like a thing, like, oh my God, right? You can't do that. When you're adding or subtracting something from a number, you cannot cancel with any other number. Okay. All right, multiplying and dividing rational expressions. I mean, you guys know this. That's not review either. You know that if you have two fractions and you're multiplying, you multiply the numerator and the denominator. But if you're dividing by CD, you have to multiply by the reciprocal. We know this. Okay, so let's do this. And when you're multiplying or dividing fractions, when you're multiplying fractions, anything from a numerator can cancel with anything from a denominator, right? So here, let's take care of coefficients first. The 8 and the 16, right? You divide by 8, I get 1 there and 2 here. Any other coefficients that I can cancel? No. So what coefficients do I have left? 21 times 2, that's 42. Let me write that down there. Okay? Now, the x's. I have 1x here, 3 on the bottom. How many am I going to have left and where? X squared on the bottom. Okay, what about the y's? I have 2 there, y on the bottom. So what goes on top? A 1. Cool. Okay, here. Whoops. Okay, I have 10 mk squared over 3c squared d. I'm dividing by that fraction. That means I have to do times 6c squared d squared over 5m squared. Okay. Let's do coefficients first, right? Okay, so here's a 3, here's a 6. That gives me a 2. What else? The 5 and the 10. Okay, so total, if I collect all the coefficients, I have 4 on top, 1 on the bottom. Yeah? Okay. M. Okay, so let's do the M's. I have 1 M on top, 2 on the bottom. So I'm going to have 1 M on the bottom. Everybody okay with that? K. I have K squared on top, and that's it. So that just stays here. Okay, C squared cancels. And then D, 1D on top. Cool. All right. Questions? Okay. Here, I have K minus 3, blah, blah, blah. When you have a situation like this, first see if you can factor something. All right. So let's see. I have K minus 3 over K plus 1. And I like to put these in parentheses. Okay. Now I'm going to combine these in one fraction. So the 1 minus K squared will be 1 minus K, 1 plus K. And then this one on the bottom will be K minus 3, K minus 1. Okay. So what can we get rid of here? Okay, the 1 minus K and the K minus 1. And remember, that's a negative 1. So let's write that so we don't forget. What else? K plus 1, K plus 1. And then also K minus 3, K minus 3. So it's just negative 1. Oh my God, who would have thought? Who would have thought that complicated old thing would just reduce to minus 1? Wow. Isn't that cool? Plot twist. Okay. All right. That's gotta go in like the trailer for this section, right? Plot twist minus 1, right? Okay. We should do like little trailers for each of the sections that I do a recording for, like episode, right? Yeah. Yeah. I mean, let's not get. Why? Okay, let's not focus on this.
No. I just wanted to know if this is going to be done.
Well, so as I had said, each unit is gonna, like each chapter is gonna get progressively harder. So by definition, yes, this will be the hardest one so far.
That's just out of curiosity. I wasn't trying to.
Okay, so we're gonna factor this. We're gonna factor out a 2, D plus 3. How do I factor the bottom? D minus 1, D plus 2. Okay, now look. There's a division sign here. So it's going to be times, and we're going to take the reciprocal of that. That means the D plus 3 that used to be on top now goes on the bottom. And then when I factor D squared plus 3D plus 2, I'm going to get D plus 2, D plus 1. See how I did that? 2 steps in one? Look at us go. Okay, so let's see what we can cancel out here. Definitely some D plus 3s, some D plus 2s. That's it, right? So this becomes 2D plus 1 over D minus 1. Yeah, right? Right? Yeah. Okay. Complex fractions, love them, but, They gotta go. We love them, but we can never leave them the way they are. Okay? We always have to simplify them. They're not illegal like having an I in the denominator, but you know, they're not cool. They're not simplified. Okay, so a complex fraction is basically a fraction where its numerator or its denominator or both are also a fraction. It's like, you know, a fraction within a fraction, a play within a play. Get it? Yeah. Okay, so you have to identify the main fraction, which in this case it's this one, and then you realize now you just have a half divided by 4/5, and then the same rules for division apply. A half times the reciprocal 5/4. Cool? So that'll just be 5/8. I know, super, super cool. Then, you know, as we progress, I'll show you guys more, you know, shortcuts and stuff with this. But, you know, we like complex fractions. They're our friends. We just can't leave them the way they are. Okay, this is the only friend that you try to change. Don't try to change any other friends. Accept them the way they are, except for these. Okay? All right. Huh? Life lessons in math. Okay, so here we go. So what I have here is this, right? In purple, I'm going to write that here, x squared over. Can I factor that denominator? Of course I can. It's difference of two squares. So that'll be 3x minus 2y, 3x plus 2y. Now, this is divided by this fraction. Divided by another fraction means the reciprocal of that second fraction. So that one in the blue, I gotta take the reciprocal of it. So I'm gonna put the x cubed on the bottom and then 2y minus 3x on top. And now, lo and behold, 2y minus 3, oh, what happened? What's going on here? Okay, so 2y minus 3x, 3x minus 2y, those are the same thing, but, you know, reverse. So that will be a minus 1. And then what about the x's? 2 here, 1 here. So I just have an x left over. So what do I have? Negative 1 over x, 3x plus 2y. Right? Fabulous. Ooh, look at this next one. Factoring. It's like 4 factoring problems in one. Do you remember back in chapter 4? Each one of these was like a problem of its own on the test. It's like factor these equations, and then it was like number 15, 16, 17, 18. Well, now all of those are in one big problem. So I'm telling you right now, if any of you are still having issues with how to factor quadratic functions, by the time you come to the next class, those issues have to be resolved. We just have to get like super quick at factoring. Okay, so we're gonna color code this again. So this is gonna be this fraction here. Okay, you're gonna have to factor that fraction. You're gonna have to factor those two polynomials in some way. So the first one, 2x squared plus 7x minus 30. It's gonna be 2x and x. And then I need two numbers that multiply to 30. So let's try 6 and 5. So let's see. This is trial and error now, right? Or guess and check. 12x, 5x. Oh my God, that would actually work if I do minus plus like this, right? That would give me 7x. Yeah? Okay. The bottom, it could either be 6x and x or 2x and 3x. Let's try 2x and 3x. Then I need to get a 5. Let's try 5 here and 1 here. What do we get? 2x, 15x. Oh my God, that will totally work. Minus, plus. Okay? So I factored that. Now, times, I'm going to do this bottom one. Okay? So here's what I'm going to do. I'm going to factor this, but it's going to go on the bottom. Correct? Okay, so you know what? That actually takes a little bit of work. So let me write it here. And let's factor that. I can take out a 4, so then I get x squared plus 12x minus 18, right? Oh, plus 3x, I'm sorry. Okay, so this is going to be 4x plus 6, x minus 3. And that's going to go on the bottom because we're taking the reciprocal. Okay. So how about this? I'll also do the other one with you guys. 3x squared minus 11x minus 4. Okay, I just want to show you this one thing. If you do this with this other method, where the 3 goes over here, so this becomes x squared minus 11x minus what? 12. And you factor that, what do you get? 4? No, 11 and 1. 12 and 1, right? Plus 1 minus 12. Is that right? Okay. 70% of you are leaving it like that. And now that's wrong. Like that's not the correct way to factor this original equation. You're forgetting to put in that 3, right? So that now it becomes 3x plus 1, x minus 4. And that, I have to say, is not sitting well with me when you forget to do that. Okay? All right. Okay, so here what happens? Cancel some things. Okay, the 3x plus 1s, 2x minus 5s, x plus 6, 2. Wow. That's it, right? So what do I have? X minus 4? 4 times x minus 3. Yeah, okay. All right, so here we go. The volume of a cylinder can be modeled by the expression x plus 3 blah 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 times pi. All right, so this is the volume of the cylinder, which could be the height of the cylinder. What is the height of the cylinder? So now again, it's never about the final answer, it's about the process. Thank you. So if we're talking about the volume of a cylinder, then we start with the formula for the volume of a cylinder. Pi r squared h, right? Remember, it's always the base area times the height. Okay, now, radius. We are given radius. Here we're given diameter to be 2x plus 6. That means the diameter is 2 times x plus 3, right? The radius then is just x plus 3. So let's go over here. Volume is pi x plus 3 squared times h. But what is volume? We're given volume in that blue box over there. X plus 3, x squared minus 3x minus 18 times pi equal to all this. Okay, so look. The pi's cancel. So what's h equal to? H is equal to this blue over x plus 3 squared. Right? You divide both sides by x plus 3 squared. Everybody with me? But now, can we factor this? What do you get when you factor? X plus, right? Thank you. So now, look at this. X plus 3 and x plus 3 together is x plus 3 squared. That cancels with the denominator. So h is x minus 6. All right?